So I know you might not have a highlighter, but I'm going to kind of show you what I mean. First of all, when we solve a linear system, we are looking for the what? Where on the graph? The point of intersection. A point is an ordered pair, right? So when we solve a linear system, you need an ordered pair for your answer. You need an ordered pair for the answer. Write that down. Come on, Chris. You need an ordered pair. That's what you're doing when you solve a linear system. Okay, so we have two equations here. One equation says that y equals this stuff, and this has x plus 3y equals 5. Well, if you notice here, there's a y here, and it says that y equals that stuff, right? And there's also a y here. So what I'm going to do is I'm going to substitute if y, watch this, a brand new concept. I should have your eyes up here. Garrett. If y is equal to this stuff, something, whatever it is, I'm going to take that stuff and substitute it into that equation where y is. And I'll show you why. Get it? Right now. Okay? Now you're like, yeah, so why do we do that? So first of all, let me just make sure you observe this. This is saying y is equal to this stuff, right? So I can take whatever y is and substitute it into here. So that's what I'm going to do. I'm going to do this. X plus 3, stop now. And I'm going to replace that y with what this y is equal to. 2x minus 3 equals 5. So what I did was this was really y in my other equation. I just substituted it in there. Look what this does for us. The only variable I have now is what? I can find out what x is. That's why it's called substitution. Now, remember, this is something I always forget to do, but I want you to start with. If you're looking for an ordered pair, you should write down right away an empty ordered pair and know that you've got to fill that in for your answer. That's what you need. So write down an empty ordered pair. Write down an empty ordered pair. Okay? Right here. All right, now I'm going to go back here and I'm going to solve for x. I'm going to have to distribute that 3. X plus 3 times 2 is 6. X minus 3 times 3 is 9 equals 5. Combine like terms, I get 7x minus 9 equals 5. Add 9, 7x equals 14. X equals 2. I'm going to take that 2, put it right here in my ordered pair. I'm halfway. I need y, because I need the point of intersection. So the easiest way is to take the 2 and plug it into one of your equations. It doesn't matter which one. Probably this one's the easiest, right? So I'm going to do that. Y equals 2x minus 3. I'm going to substitute in the 2. Y equals 2 times 2 minus 3. What does y equal? 1. 4 minus 3 is 1. Boom. And I have my answer. Okay? That's what I'm looking for, the ordered pair, the point of intersection. This is using substitution instead of graphing. Let's do another one. Now, they're not always going to be in the right form to substitute. It doesn't matter if you get x by itself or y, whatever's easier, because you can just substitute that value. So this one here, which equation do you think it would be easier to get one of the variables by themselves? Probably the first one. Doesn't really matter. So I'm going to take this one, and I'm going to solve for x. So I'm just going to write this like this. This is what I started with. X minus y equals 3. I'm going to add y to both sides. And I get x equals 3 plus y. Okay, now I can substitute. I'm going to take this value for x and substitute it into my other equation where x is. Because I'm saying x is equal to 3 plus y. So I can substitute it into the other equation. And it will look like this. 3 plus y, substitute it in for x. Don't forget this part, plus 2y equals negative 6. And now I have all y's. What did I forget? What did I say you should always start by doing? Write your empty ordered pair. That's what your answer needs to be. So, okay, let's go back up here. Combine your y's. So we have 3 plus 3y equals negative 6. I combined 1y and 2y. Subtract 3. And divide by 3. Like I said, this part you should be pretty efficient at this point. So y is negative 3. I'm going to stick that into my ordered pair. That's part of my answer. Then I got to get x. So I look back at what I'm working with here. I could plug y into here, or here, or here. Which would be the easiest? Probably this one, right? To find out what x is. So I'm going to do that. X equals 3 plus negative 3. My y was negative 3. What's my x equal to? 0. So that goes into my ordered pair. What do you think so far? Not bad? Okay, let's do another one. Sometimes they're not always quite so easy to move around, but you still have to decide which one you're going to move. We have this equation, and we have this equation, and we need to get one variable by itself. Which one do you think? Probably the first one, because there's no number in front of the y except a negative 1. Okay, so I'm going to put an arrow here. I'm going to choose to move this one and get y by itself. So I have to add 5x to both sides. That's one way to do it. Could add y too. It doesn't really matter how you do it. Okay, so I'm here. Is y by itself yet? It's got a negative 1 in front of it, doesn't it? So I have to divide everything by negative 1. So I'm just going to do that. All that does is changes the sign of everything. Okay. Now I'm ready to substitute. If y is equal to this junk right here, I can take that and place it into this equation where y is. Now let's see what that would look like. You still have 3x minus 5, and you stop there, and you're going to put this stuff in for y. But you should put it in parentheses because you have to distribute that 5. So I stuck that stuff in for y, and it equals 4. Now we'll get some funky signs going on here. So I'm going to change this to adding a negative. Change this right here. And then I know I have to distribute a negative 5. So I don't screw up with the signs. Distribute 3x plus 60 plus 25x equals 4. $28x plus 60 equals 4. Oh, I did it again. Oops, I did it again. I should set this up. Did you? Very good. Subtract 60. Negative 56, and x equals negative 2. So, stick a negative 2 in there for x. I'm halfway there. I need to figure out what y is. You can stick negative 2 for x into this equation, or that one. That was probably the easiest, isn't it, to figure out what y is. This one, or that one. It doesn't matter. So I'm going to stick it into this one. Y is equal to negative 12 plus negative 5 times negative 2. Y is equal to negative 12 plus 10. And y is equal to negative 2. So, this is my point of intersection, my solution. Doable? Oh, Lord, look at that one. So, I did it. Sometimes I feel like the things that are in these notes, which I don't make, are a little bit too hard, but so it's a lot of work. I'm not going to do this one with you. I'm not saying you're not going to get some that might have fractions in them, because you might. And they're doable, they just take a little while. It's the same process. You just got to take your time with the fractions. And if you're curious to come up and take a look at this, certainly you can. You end up with an answer that's not a fraction. But we're not going to spend time doing that right now. But you can come up later if you need to. Okay? You will see a couple with fractions. So turn this over. All right. You're going to have a couple story problems, but you have to think, I know that I'm working with systems, which means I need 2 equations. Each time I have a story problem here, I need 2 equations, or 2 inequalities. Here it's equations. A food cooperative is a business that usually offers special prices on locally grown food and produce. Some cooperatives are clubs and others are retail stores. The weekly costs for seasonal produce offered by a club-based and a store-based food cooperative are shown in the table. Find the number of weeks. That's my unknown. Find the number of weeks at which the total cost of weekly produce will be the same. X equals number of weeks, or weeks. That's what I'm looking for. Instead of using Y, I'm going to say C is cost. I have to write an equation for the club and an equation for the retail. So if we read this table here, it says the club has a fee of $20 and a weekly cost of $15. So the cost to be a member of the club is, what's the fee? $20 plus how much per week? 15x. There's one equation. For retail, there's no fee, and it's $17.50 per week. So my cost for retail, no fee, and $17.50x. So I have 2 equations. What I need to know is find the number of weeks at which the cost will be the same. I want to know when the cost of the club is equal to the cost of the retail. Basically what I'm doing is I'm saying, okay, look, C is equal to this stuff right here, right? So I can substitute this stuff in here where C is, can't I? Correct? Or this is C, I can put it there. Basically what I'm saying is the cost of the club is 20 plus 15x. I want to know when it's equal to the cost of the retail. And now I just have x and I can solve it. I don't really need an ordered pair here because all they're asking me for is weeks. All right, so I'm going to subtract 15x. 20 equals 250x. When you divide by 250, you get 8. X equals 8. And what does 8 represent? 8 weeks. I could find out what the cost is easily. I could get my ordered pair, but I don't need to. So all they're asking me for is that. So in a sense, we substitute it in. All right, last one. You burned 8 calories per minute on a treadmill and 10 calories per minute on an elliptical trainer for a total of 560 calories in 60 minutes. How many minutes did you spend on each machine? This is my unknown right here. I have 2 machines, so I'm going to say X is the minutes on the treadmill. Y is the minutes on the what? What's the other machine I used? Elliptical. Let's look at this story problem. We're talking about calories and we're talking about time. And I need 2 equations. So I'm guessing that I'm going to have to write a calorie equation and maybe a time equation. 2 equations. What information involves calories in that story problem? What I have. How many calories per minute on the treadmill? 8 per minute on the treadmill. Plus 10 per minute on the elliptical. And I burned how many? This equation involved all the calorie information, didn't it? The other one is the time. How long was I on it altogether, exercising? And I had minutes on both the treadmill and the elliptical. So it's just X plus Y equals 60 minutes. Time equation, calorie equation. Okay? Oh, I can use substitution to solve this. I do need an ordered pair here. I need an X and a Y. So I'm going to move this one because it's the easiest to move. You want to get Y by itself or X by itself? You get Y by itself? Okay. So that means I'm going to subtract X from both sides. I have 60 minus X. Now I can substitute. If this stuff is equal to Y, I'm going to put it into this other equation where Y is. So let's write it. 8x plus 10 times 60 minus x equals 560. Oh, I just have x's now. I can solve. Distribute 8x plus 600 minus 10x equals 560. Combine like terms. 8x take away 10x will give me negative 2x plus 600 equals 560. Subtract 600. Negative 2x equals negative 40. No. Yep. And x equals 20. So I'm going to put that right here. X equals 20. Really, really, really super easy to take x equals 20, stick it in here. What is y? 60 minus 20, y is 40. Okay, so what does that tell me? I spent how much time on the treadmill? 20 minutes, and how much time on the elliptical? 40 minutes. Cool, huh? Next time you're exercising, you could do this in your head while you're on the elliptical and the treadmill. Oh, I could write a system, because I know you want to.